Right, you're welcome back again. We are continuing from where we stopped. This is a parametric test, and we have looked at different kind of parametric tests so far. So we want to continue from where we stopped and look at independent unpaired sample test. Unpaired is different from paired. We just finished paired sample test, and in our last class. So in this section, we want to look at some unpaired sample test, which focus on one numerical and one categorical, and which must have two groups only. Don't forget two groups, two groups, and these groups are independent groups. All right. When it's more than two groups, you are now dealing with ANOVA. Okay, you are no more dealing with a unpaired sample test. Okay, but we are dealing with only two groups. So when it is two, then you use this particular test on independent unpaired test. So what does it really mean? It means to compare two independent groups, to compare the mean of two independent groups or samples. Just two, right? Take note of that. We might have another example of this test in form of maybe is want to say that is there a difference between people who have a college degree and people who do not have? So we find the means. So we already have two groups in our categorical data called education, for example, education, college degree, no college degree. So we want to look at is there a difference between the people who have and who do not have by looking at their mean, all right, in terms of their health, okay, maybe PB, right? Okay, so we use PB as our continuous variable, while you use education as the categorical variable. So we have college degree, no college degree. Okay, so maybe you want to do another example. Maybe do two production lines produce screws with the same weight. So we have weight now as our continuous variable, and we have production lines. We have two production lines. Okay, that produces screws. Okay, with the same weight. So that one automatically has two as a production line A, production line B, which automatically have two groups in the categorical variable. Then maybe you want to say that do smokers have a high risk of heart attack than non-smokers? So we already have a continuous variable there, and we also have a categorical variable called heart attack. For example, high risk. I mean, we have non-smoker and non-smokers. So these are our categorical variable. We have two groups: smokers, non-smokers. You see that? So based on the risk of heart attack. So that's our continuous variable. We want to compare that with our particular variable, which is smoker, non smoker. All right. We also can say that is there any difference in the salary of men and women in the ABC company? We have salary already as a continuous variable, which is measured in US dollars or other currencies, and we have a categorical variable including two groups, men and women. You can see that it's very straightforward. It's different from the one we did with before, which is paired. All right, that one is talking about different entirely. The same set of people measure twice, before and after. The same set of people measure them before the administration of anything that you want to administer to them, and after. Okay, so we now run the test. That is paired, but this one is unpaired. Okay, this one is different. So you can see that it's clearly different from the previous ones, right? So we have a categorical variable that have only two groups, and we have a continuous variable. So that is how we measure independent. So this particular variables, they are independent. I mean, the groups we have the independent groups. Male is not dependent on female. Smoker is not dependent on non-smoker. Okay, the college degree is not dependent on college degree, so they are independent groups. All right. Okay, so here we will use a sample data set which contains the weight of 20 individuals, 10 women, 10 men. So we're going to curate that. So let's create just to demonstrate. We can create using women and men. Let's pass in and let's create weight. So let's now combine together as usual. We want to pass then so we have 10 men and 10 women. So now what we want to do now, I want to test right? To test whether the means weight differ between genders, right? We have two groups now, men and women in the gender. We call it gender. Okay, that's our group, our categorical variable. Then we have continuous variable called weight. So we want to test, does the mean differ between the gender, or we want to know if the average women's weight differs from the average men's weight. All right. So let's just create a plot and let's check our. Let's attach this weight data so that we can use our this directly instead of using a dollar sign to invoke our variables. Just call the variable straight instead of so now let's first plot. We pass our ggplot here, our data set name. Say gender x-axis to be the down, our weight will be up. Okay, want to fill by gender to see the color, different color. All right, so let's run this and see the result. All right, so this is what we have. We have man, we have woman. Okay, this is our gender. Then we have weight here. Behind this thing, you can see the weight is not the same. Okay, the average is different, right? You have different mean. You can also want to confirm there by running the summary here. Okay, let me just run the summary. Okay, yes. So we just say group by weight. We pass in our data set gender. Now we can remove this because we already attached our data or attached already. So you don't need to use that one anymore. If you are not attached, you can do that. Now we have attached. I can just pass my gender straight, summarize, then find the mean. So let's run and see what I'm talking about. Oh, there's an error here. So let me return it back. I think there's a problem here. So I don't know what the problem is. Okay, good. All right. So gender. Here we have man and woman. We have count. We have mean. You can see. We have SD. So standard deviation. So that is just how to group, how to summarize them. So take note of this simple method of summarization. It will help you a lot when you are dealing with your data set. So we just count to see the number of observation in the individual set of the group. Okay. Now we want to you can see that the man weight is higher than that of woman. Okay, but we want to know whether this difference is significant, right? An independent sample test can provide the answer. Okay, the man and the woman in our experiment are the independent samples. Don't forget that that is our categorical variable, but we need to check assumptions first. So let's now check assumptions now. Number one, are the data from each two of the two groups follow a normal distribution? Let's use Shapiro test now. So now we have attached our variable. We can pass Shapiro test here. Just use weight again, weight straight instead of using the table name dollar. So let's just run this. Okay, we have 0.293. So the null hypothesis of normal distribution is not rejected, so we can continue with a t-test that assumes normality. So we pass the Shapiro test, right? Are the variances of the two independent samples equal? We need to use Levin test to test this, all right? So we pass our weight here, our variable here. So we need to factor it. If not, it will give error. But let's just run it first and see. Okay, that's what I'm saying. So we just factor gender here as usual. Factor, right? Gender. Always remember this, okay? So that you will not be running to this a warning. They do not stop your code from running, but at least so you can see now it's okay. So we have a Levin test for beginning inference. Now we have a 0.2 which passed the test, right? The null hypothesis of the equivalence is not rejected. The p is also 0.2, 0.02 approximately. So we can continue with the test that assume equivalence. So now that we have passed the test, so we can now run our test now. T-test. See the same follow t-test, okay? Wait, our continuous variable is passed here. Don't forget what the continuous variable is, okay? And then what categorical variable is. You can go back to my previous videos and watch so you can understand what I'm saying. Then we have our gender here, right? We have our now we now say variance dot equal to true. That is what make it unpaired now. We say var dot equal equals to true. So we run this line. So that is what make it unpaired. So let's run. Now you can see now we are having two sample t-tests. We have t equals to this, degree of freedom is equals to a thing p-value equal to 0.006, which is significant, less than 0.05. Alternative hypothesis: true difference in mean between group man and group woman is not equal to 0, which is significant. You have lower band, upper band of confidence interval. The sample estimate for mean of man is 68.9, and for woman 52. Is that correct? What we got in our, let's check, 68.52. Let me see. I think we're wrong now. Okay, 68.52. That's correct. That's correct. So not far too much from what we got. Okay. So now this is our test. So we can report. I say we report this as follows: men and women differ in the degree to which they are weighted rather. We have our t equals to this. Okay, move a minus, right? That is a direction, just to show the direction of the movement. So we have p equals to 0.6, is significant. The p-value of the test is 0.0061, which is less than the significant level of alpha 0.05. We can conclude that men's average weight is significantly different from the women's average weight. Right? Note that if you want to test whether the average men's weight is less than the average women's weight, you can also use the alternative approach. Okay, remember that. So just supply the same thing here and then comma and add alternative equal to less. Okay, that is what you do. Okay, I don't need to run that anymore, so you already understand the concept. Now when you are done, you can detach your data, the weight data. So you can use that. You should not follow the other data set you are running. Just detach. Don't forget we attached first. We have to use our variable straight without using $sign. Now when you are done, you just detach. Just run detach here. Okay, to be detached. Then that's all. So I think you enjoyed the class. If you have not yet subscribed, you can subscribe to continue enjoying. Getting more videos that will be posted on every week, so that you will not miss anything. So I will see you in the next. If you have any question, you can post it, or any comments, you can put in the comment section. I will graciously reply. Thank you so much. I will see you in the next class next time.